Second is pre-cal. First is my conference on A days. Why?
Because I don't have
Yes,
the
no, maybe.
first bid. Right, and budget. So
Tomorrow?
Yeah.
Tomorrow is PSAT. Do you remember that?
What are we doing?
All right. Hey, Anaya, you didn't pick I do or I do not on your form, so I put I do. Do you care about being in that video?
Oh, no.
Okay, you had it signed, you should pick it.
Oh.
Alright, take a look at the top. We'll do maybe like 2 of these, we'll do 1 and 3. Okay, number 1, is it already equal to 0?
Yep.
Then we're ready to solve by either T-chart, perfect squares, GCF, or grouping. What are we doing for number 1? T-chart, so it'd be A, B, C. Set up your chart. My A, if it's not there, is a 1. So that's 1 times 20, which is 20. Note that it's a positive 20. That means this is an addition chart. Okay, and then what will times to 20? 120, 210, and 4, 5. But we need our numbers to add to 9. Who are we picking? Okay, and then if I want them to add to a -9, then I need to use both negatives. Remember, for addition, the signs have to match. So they're either both pluses or both minuses. Okay, then from there, can I shortcut?
Yeah.
Yes, because A is a what? 1. So if you don't have a number on that x squared, that means you can go straight to your parentheses. X minus 4 and x minus 5. Then remember, because it equals to 0, your solutions just come out to be the reverse. So if it's an x minus 4 equal to 0, then how would I get rid of the -4 to get it across to the other side? So it comes out to be a +4. Can you shortcut straight to the answer? Absolutely. What about for the x minus 5? If I said that equal to 0, it would come out to be a +5. Okay, real quick, before you do number 2, can you ABC that in the form it's presented in? And no, what are you gonna need to do first with that 5? Yeah, so technically we're subtracting it to move it. So you would end up with 0 equals 2x squared plus 9x minus 5. And then from there, you can ABC it, but make sure you have to get everything on the same side first. Okay, I'm not gonna finish that one, we're gonna do number 3 instead. Okay, number 3, can you GCF it? PT chart it? Perfect squares it? Then it's already factored, so I'm gonna keep it, 7x minus 12 equals 0. And then remember, I can either set it equal to 0 or just memorize the pattern. If it's a 7x minus 12, how do I get rid of the minus 12? I would add it across, and then where does the 7 always end up if it's on the x like that? Divide it to the bottom. Okay, but can you solve it step by step? Sure. Okay, but if it can't factor, that means it's already done, and you just pick your answer from there. Okay, remember you're switching the sign and then dividing if there's a number on x. Any questions on that? Okay. Let's go to number 5 or 6. Want to do 5?
Yeah.
Okay. Number 5, you're finding the exact same features over and over and over again for this test. You got to know what each number does. Okay, for number 5, for horizontal asymptote, what rules are we using to determine the asymptote? Remember the names of them? Yes, Bobo? A, Bobo, Boston, and Betsy. Okay, and then, do we need to review what those stand for, or we're good?
We're good.
Okay, so then looking at number 5, what type would this be?
Fine.
Huh? Button, okay, good. And it's bigger on top, so that means button is bigger on top. What's the N?
No,
Yeah, none or no horizontal asymptote. Okay, every other feature you have to know how to factor. So if I take a look at the top of that, what can I take out of all 3 of those? Okay, good. So I'm gonna go ahead and GCF that X out first. And so now my X cubed is knocked down to an X squared. My minus 3X squared is a 3 regular X. My minus 4X is just a minus 4. Is that done? Is that broken down all the way?
no,
What are we gonna still have to do here? T-chart, very good. So I'm gonna now T-chart that second part. So I know I'm gonna have an X in the front, but I still have to T-chart to break it down to where each X is alone. We don't want an X squared, we need X's individual. So I'm gonna have a -4 at the top of the chart. I could do 1 times 4 or 2 times 2. What number do I want in the middle though? A -3, and I'm subtracting, so what number is minus to 3? Where will I apply the negative, the 1 or the 4? Negative on the 4, because if I want it to be a -3, I need the bigger number to be the minus. So then for the top, we're gonna have X in the front, X with a +1, and X with a -4. Okay, for the bottom though, it's just gonna be one easy step. I had an X squared minus 4X. What can I do to the bottom there? Okay, so I heard GCF and square root. Can I square root 4 by itself? Yes, what about 4X?
no,
No, it would have had to been evenly split. I can't split the X part of that, so I'll have to do GCF. So we're gonna GCF out of 4X. Or wait, no, not a 4X, just an X, sorry. And then what's gonna be left over when that X comes out?
X minus 4.
Perfect. Okay, then we have to just remember, okay, what things come from where? So holes, what factors create holes in the graph? Okay, the ones that cancel out. So if I can cross out X minus 4, that means that the hole is gonna be where? At 4 comma something. And what else did we say we can cross out? The X's by themselves can also cross out. So I'm gonna actually end up with 2 holes in the graph. For my second hole, if it's an X on the outside, what number would that be? 0 comma something. We'll fill in those Y values later. Okay, if you struggle to remember which one's which, I would encourage you to write holes and then put cancel out. Okay, where do I find vertical asymptotes in the equation? Okay, the bottom that don't cross out, are there any? Okay, so I'm gonna put none. And I'm gonna put bottom. Okay, because there are no X's left on bottom. What about for the top? That creates x-intercepts. Another name for x-intercept is a root. Okay, you should know that, but just in case, an x-intercept and a root are the same, those come from the top. So do I have any left on top? I have a +1, so the root will be at -1, and remember the Y value for an x-intercept is always 0. Just like the X value for a Y-intercept is always 0. So for a Y-intercept, your X is 0, X-intercept, your Y is 0. Okay, from there, we need to use our calculator. This is where hopefully you picked one up. But remember, you're only plugging in the parts of the equation that did not cross out. So when I go into my calculator here, I have an x plus 1 on top. If there's nothing on bottom, what should you put as a placeholder? 1. You can't put nothing or it's gonna say error. Okay, so if there's nothing left on bottom, put a 1 as a placeholder. Okay. Then from there, I'm looking for 4's partner and 0's partner. 4's partner looks like is 5, 4 comma 5. And 0's partner, it looks like is 1. Then when I come down to my y-intercept, I notice that that would also be what? 0, 1. But can you have 2 of those in the same spot? No. So if there's already a hole at 0, 1, then does it really touch the y-axis there, or is that point missing? It's an open circle, right? So this no longer counts. So I'm gonna put already hole at 0. Okay, so you should not have features on top of each other. The only exception to that is that if your x and y intercepts are both the origin, those are allowed to be on top of each other. Okay. Any questions on that? All right, go ahead and turn the page for me. And then we're just gonna do one of these where you have the graph and you're going backwards. We'll do number 9. Or, actually, we'll do number 8. Okay, take a look at number 8. Do you see any holes drawn into that graph? Okay, what x does the hole occur at? I don't want the whole ordered pair, just the x value. So 1, 2, 3, 4, 5, 6, yeah. And the whole point of this on your test is that you're writing the equation. So let's go ahead and do that as we go. Y equals big fraction. So if there's a hole at +6, what would the factor say? And where would it be, top, bottom, or both? Okay, so x minus 6, x minus 6. Okay, the next thing I want you to look for are the vertical asymptotes. Vertical asymptotes, do I have any? Okay, can you tell me what numbers they happen at? Okay, very good, at +3 and -2. Where do those features show up? Okay, so then my factors would be x minus 3 on bottom and x plus 2. Next thing I'm looking for are roots. Roots are the same as an x-intercept. Remember, same exact thing. So I'm gonna put x-intercept. And where do my x-intercepts happen? We're gonna round these to whole numbers. So what would this be? Just estimate 1 and -3. Oh, wait, hold on. Oh, it's -5. I counted wrong. Remember, you gotta start from here.
Oh, yeah.
So it'd be 1, 2, 3, 4, 5. And then where do those features go? Top, bottom, or both? Top only. So if it's a 1, I'll put in x minus 1. -5, I'll put in x plus 5. Okay, is there a y-intercept on this graph? Okay, where is it crossed at? Just round it off to a whole number. -1. And then I'm gonna put a little hint here. Okay, that's not in the equation. Okay, you should be able to find it just because we've been using them to help graph, but you don't actually need that for the equation. Okay, what's the only thing I have not found so far that I skipped? Okay, horizontal asymptote is gonna be the one that drags across this way. So I see that I have one. How low is it? -2. And now if you have a horizontal asymptote, if it was at a 0, it would have been a bobo. If it didn't have one, it would have been a bottom. So if it has one at a number, that means it has to be a bed C. So look at your equation you wrote, is it a bed C? Yes, it is, very good, so I'm gonna put right here. This means it has to be a bed C. And then I could put a little check by that, but then I need to make sure that the numbers that I place in the front divide to -2. So what numbers could I put there? There are a whole bunch of choices. Okay, -4 divided by. You could have put -20 divided by 10, -80 divided by whatever it is, it just has to divide back to that number. Does that make sense? Okay, before I give you some time to work, okay, on the next couple of graphs, I just wanna make sure that you see where the horizontal asymptotes are and where the X and Y intercepts are. So for number 9, it's not dotted, this is the asymptote. There was some confusion about that in the last class period, and then these are the asymptotes. Okay, those really should be dotted lines, but I just pulled this graph off the internet. Okay, then the X and Y axis are where the little x and the little y are. So do you see the little x right here? That's the X axis. And then that's the Y axis. So then that would be 0, 0 in the center. So if you want to just mark that for your test, I'll make sure that the asymptotes are dotted lines. So it's not quite as confusing. Okay, then I would say for your x-intercepts on that one, you can round this one to a whole number, but I would give this one like a 0.5. So that's 1, 2, 3, 4 and a half for that. It's not really close enough to just like push it to one side, you know? All right, then turn the page, you have one more graph. And we're just gonna mark it up the same way. So do I have any vertical asymptotes on the second graph? That I could, any lines that I could slide in that would be asymptotes? Okay, yes, they're not drawn for you, but I want you to draw them. I draw right here at -2. Do you see how that perfectly slides between the chunks of your graph? Okay, then there's an asymptote there. It's not drawn, but you should be able to kind of picture, read between the lines a little bit, that if your graph's shooting up and down at that point, that's an asymptote. Where does the other one occur at? For you, friend. Okay, one more question. Do you have a horizontal asymptote? No. Do you have a different kind of asymptote? Slant, or what's the fancy term, starts with the O? Oblique. Okay, so this is also an asymptote. Okay, now, quick question. If there's a slant asymptote or an oblique asymptote, should it be a Bobo, a Botan, or a bed C? You remember how to tell? So Bobo means it's 0. Bed C means you divide the coefficients. Okay, Botan is where you don't have a horizontal. How do you know if you have a slant under the bottoms? Top has to be how much bigger? 1 power bigger. So I want you to put right here. Your equation should be a Botan with the top exactly 1 power bigger than the bottom. Now, you don't have to find the slant asymptote, but because you see it in the picture, you should be able, when you write the equation, to be like, oh yeah, I got 1 more X on top than I had on bottom. Okay? All right, so your goal is to work through 1 through 10. We'll come back and do an example from the second half in a little bit. Okay? But please ask me if you need any help. Okay? Yes, there's a path right by the pencil sharp. Okay, so 1 through 10 is what you're working on, please. Okay, so we're just gonna do two more examples together. So if you'll turn to number 14, okay, number 14.
No.
Okay, that way when y'all get back from lunch, we're kind of done doing questions all together and y'all could just finish on your own. So 14 is the next one that we're gonna do. Okay, first question, is it a bobo, a bottom, or a bed seat for number 14? Okay, it is a bottom, that means bigger on top, none. Okay, however, if it's bigger on top by exactly 1 degree, then what can it have? An oblique or a slant asymptote, and is it gonna have one here? Yes, so I want you to put down here, slant asymptote. And then we're gonna review how to find that. Okay, it does not have a horizontal, but it does have a slant. Okay, and we'll find that at the very end. But I'm gonna write slant asymptote so that we don't forget to find it later. Okay, all the other features you have to factor for. How will I factor the top? Can I T-chart it? It's grouping, very good. So I'm gonna write grouping here, and then I'm gonna show the work for that at the bottom of the page. Okay, but the top is gonna be grouping. What is the bottom gonna be? Okay, perfect squares or square roots. Okay. So let's go ahead and factor that out using this space down here. Then we'll write our final answer right here. So for grouping, remember you are going to group the first 2 terms and the last 2 terms. And then look for what they have in common. So I just rewrote the problem down there to do grouping on it. What can we take out of that first group? Okay, x squared. When the x squared comes out, what's left over? X minus 2. Out of the second 2 partners, okay, they don't seem to have anything in common, then I can take out what number? A 1. Anything else I should take out? Okay, you got to take out a negative as well. Out of my negative x, now it's just an x, because I pulled the negative. What about from the plus 2, if I divide it by negative 1? And remember, the whole point of that is that your parentheses ought to match each other, do they? X minus 2, x minus 2. Okay, then the other parentheses comes from what got left out. I took out an x squared and a minus 1. That forms your second parentheses. Remember, fully factored means no more x squared. They have to each be in their own parentheses. So how can I break down now this second part? Okay, square roots or perfect squares, that's the same thing. So I'm going to square root my x squared. That's going to split into an x and an x. What's the square root of 1? Plus or minus 1, right? Because you got to have 1 of each. And then don't forget that x minus 2 that you had already broken down. That should just kind of stay in the front. So now check, the top is done. Once you have that written down, I'm going to copy that in the space right underneath number 14. So up there at the top, I'm going to have an x minus 2, an x plus 1, and an x minus 1. Okay, so it should look like that. Okay, on the bottom, I had an x squared minus 4. We said we're square rooting that. So the square root of x squared is going to split into what? It'd be x and x, right? And then for the 4, what's the square root of 4? Plus and minus 2. Very good. Okay, looking at your equation, now that we've factored it, where will there be a hole? Okay, the minus 2's cross out. Then there will be a hole at +2 comma something. Vertical asymptotes come from x's left on the bottom. Will there be one? Okay, where? -2. X-intercepts come from top leftovers. Will there be any? Yes, where? Okay, so there'll be a -1, 0 and a +1, 0. And then my y-intercept is whatever zero's partner is. I'll need to use the calculator to find that here in a minute. Now, out of all those features, okay, I can actually graph a couple of those right now. So can we graph our x-intercepts? Where are they supposed to be at? -1 and +1. Okay, and then a vertical asymptote, I could graph that right now. Okay, x equals -2 would be 1, 2 right here. So then I'm gonna draw in that vertical asymptote. Okay, but for the hole in the y-intercept, you really need to know the entire ordered pair to graph this. So in your calculator, you're only typing in the parts of the equation that did not cross out. Specifically, that would be an x +1 on top and a -1. Yes, ma'am. The patch should be right over there by the sharpener. Okay, and then remember, you're checking your table to find those y values. Oh, okay, he's got it. So I see 2's partner is 3/4. And then I see 0's partner is -1/2. So -1/2. Remember, if those decimals come out ugly where you can't like estimate it, just divide it in your calculator. So for example, let's say we didn't know 3/4, second quit, 3 divided by 4, that's 0.75. So then I'm gonna go ahead and write here, that's really 2, 0.75. Okay. So let's draw that hole in. So go to 2 and then go up 0.75 of the box, not the whole way up, but a little bit above half. Then your y-intercept is 0, -1/2. If you want to decimal that, bless you, that'd be 0, -0.5. So that'd be right here. Okay. What's the last thing we still have to find? Slant. Now, I'll tell you that for your test, okay, since I know long division sucks and slant asymptotes aren't really that important beyond this one unit, okay, it's gonna be a bonus. So if you wanna put right here, the only time you're gonna have to find a slant asymptote is gonna be the bonus on your test. Okay, but I do want us to review it just because we've covered long division. And I'm hoping you haven't forgotten it. So remember, for the slant asymptote, you do the top, divide by the bottom. Okay, but you pretty much always have to use long division unless it's like a nice, easy, like x -2 on bottom or something. So the top was an x3 minus 2x squared minus x plus 2. And we're gonna divide that by x squared plus 0x minus 4. Now, you should remember that if it's an x squared minus 4, you have to fill in any gaps. That's where that 0 is coming from. This has to be there. Okay, otherwise you end up with stuff not lined up to where you can't work the problem. Okay, so don't forget to fill in any gaps. All right, here we go. What would I times x squared by to perfectly match an x cubed? Put an x on top. Then I'm gonna take that x and I'm gonna times it by all 3 of these and line them up. So x times x squared is x cubed. X times 0x is 0x squared. X times -4 is -4x. what do I do with the signs on that row then? So it's gonna go minus, minus, plus. X cubed minus x cubed, what happens there? Cancels out. What's negative 4, or I'm sorry, negative 2 plus 4 minus 0, it doesn't matter. Still negative 2. And then for the last one, that's a negative 1 plus 4x. What's the next term? 3x. And then carry down plus 2. Bless you. Then we're gonna ask ourselves the same question for long division. What would I times my x squared by to perfectly match a negative 2x squared? Okay, then I would take the negative 2, multiply, subtract, but do I have to do it? No, this is your asymptote right here. So I'm just gonna put blah, blah, because you don't have to finish it. Okay, you don't care about the remainder. It doesn't change anything. Your answer is what you got right here on the top. So just put a y equals on x minus 2. That's your slant. Okay, so let's graph that into our picture and then we'll be finished with this question. So minus 2 is the y-intercept. That'd be right here. And then remember that if it's an x, that's like a 1 over 1x. So I'm gonna go up 1 over 1, up 1 over 1, up 1 over 1. I can also go this way, down over 1, down over 1. But remember, this is an asymptote. So what kind of line should I give it? Solid or dotted? Okay, asymptotes should be dotted because they guide the shape of your graph, but they're not actually part of the graph. So I'm just gonna connect every other dot to get my dotted line. Okay, then from there, hopefully now you can see how we're gonna connect the dots. We're gonna have a little slice of the graph up here. And then usually the other slice is catty corner, it'll be down here. Okay, but we can always hit graph in the calculator, okay, to double check that our work looks good. So I'm zoomed out quite a bit, but you can see that slant asymptote coming in. And then you have your 2 chunks, just like hopefully we would have expected. So one piece is up here, draw it in. And then the other piece would be somewhere down here. So the only actual pieces of your graph are those blue. These lines are more guiding lines that you can't touch. Questions on that? Okay, last question I want to go back and revisit is number 7. Okay, number 7, you are asked to write the equation given the different features. Okay, so if you'll take a look at number 7. Okay, it says write the equation with the following characteristics. How will I put a hole at x equals 2?
X minus 2 cancel out.
X minus 2 needs to cancel out, which means it needs to be top and bottom. Okay, next feature, I need to have a root at 0 and a double root at 5. What would a root at 0 mean my x goes? That was a bad question, but you know, in the front, thank you. Okay, x equals 0 means your x needs to be in the front. And then x equals 5 means it's an x minus 5. How do I turn that into a double?
Square.
You're gonna put a squared. Or if you want to write it twice, that's the equivalent, that's fine. Okay, vertical asymptotes, I should have one at -2 and +3. Where do those go? Okay, x plus 2, x minus 3. And then the last part of that says I want a horizontal asymptote at 0. If I had a horizontal asymptote at 0, should it be a Bobo, a Botan, or Betsy? Okay, if it's a horizontal asymptote of 0, it should be a Bobo, but how many x's are there on top?
Yeah.
Not 3, 4, because remember this one counts twice, so it's 1, 2, 3, 4. And on bottom it's 1, 2, 3. So can this be a Bobo? No, this is a button, so I want you to scratch that out and put none. Okay, that's a mistake that I wrote this, I just messed up. Okay, you cannot have a Bobo with more X's on top, that doesn't make sense. Okay, so you have all the rest of class to finish. You'll get the answer key via email through Focus. And then your test is Wednesday. It is an early release day, so it won't be like a billion questions long. Okay, you gotta know how to factor. If you need help with that, I'll be here after school today. Good job.